A conventional oil and gas field usually is something like this. There's a what's called a cap rock that oil and gas can't go through. It can be a geological slip joint like this. It can be a layer of salt or certain kinds of very impenetrable sandstone. And so hydrocarbons are normally generated in what's called source rocks, and the source rocks tend to be deep, and they make, from ancient plants and animals, they make essentially they pressure cook ancient plants and animals for 100 million years, and this turns them into oil and gas. Let me give you an idea that you can relate to. If you take a piece of wood, you take a piece of tree, or you take a piece of any living material, often the carbon structures are hundreds of thousands of carbon atoms long. Now, to make the optimal size stuff to use in a car, you want carbon that's 8 carbons long. That's octane. That's why we say that gas is 90 or 93% octane, means it's 93% as good as if it were made entirely from octane, because that's the optimal length for carbon to be. So what happens over a long geological period is this gets snipped into smaller pieces. It becomes light, moves up through the earth, and it gets trapped in a structure. Now, that's the easy stuff. You drill one hole down, you hit it, you've got gas on the top, then oil, then usually brine from the ancient lake or marine environment in which it's formed, and you pump it out. That's easy, it's dense, it's high quality, and that's what we built our country on, and we're still basically running on that stuff now. But we're coming towards the end, at least the end of superabundant supplies of this. And so instead of just drilling a hole down in the ground and hitting either all gas or gas plus oil, you go down and you hit what are shales. Are just shales like if you drive along Route 20, the black rocks along the edge. Well, there's not a whole lot of gas there. You can tell. You can smell it. Doesn't smell like gas. You can light it. Probably won't burn, or barely will burn. But if you got enough of it, you can. There's enough molecules of gas in the whole structure so that you get a significant amount out. Do you understand? But you got to get a lot of it. And so what you got to do is, it's almost as if you've got to break up. You got to crush huge geological formations of shale to let out those relatively few molecules of gas. So how we do this now is new technology, only 10 or 15 years old. You drill down maybe anywhere from 1,000 to 10,000 feet, 2 miles, into the earth. Let's say you go a mile into the earth, and then you turn the corner with the drill. Woohoo! That's very complicated stuff. And then you drill horizontally through the formation. Now, you're not drilling into a bunch of gas. You're drilling into rocks that have a little bit of gas. And how you get that gas is you got to break up the rocks so you can liberate the molecules of methane, of gas. And we do that with high water pressure. So you put in very strong pressure. You can break up the rocks, release the gas, and the gas will come out the pipe, and that's called hydrofracking. Is the process of breaking up the rock with very high water pressure, and that's how you get the gas. It's a very complicated situation. It requires very, well, completely new ideas about how to drill for gas, but it works, and you can get significant amounts of gas from shale that was formerly useless in terms of getting energy from. Now, here's what can happen. First of all, you got 1,000 big trucks coming into some remote little rural area, driving over bridges, often raising dust, making a lot of noise, sometimes breaking bridges because they're very heavy trucks, just being in general kind of an annoyance. That's the first thing. The second thing is they try to bring the fluids back out of the grounds. Well, the fluids have got all kinds of stuff in it, including the chemicals they put in to make the gas flow better, but also including the all kinds of stuff that's from the ground itself. They say they hit a deposit of sulfur or something down below. Okay, so the water comes back out, and then what do you do with it? You can't just dump it in the neighboring creek because it's all polluted. Well, some people want you to put it back in the trucks and take it to a sewage treatment plant and treat it. And even that can have some problems. So, what do you do with that water? Okay, a third thing that can happen, it's the water that we drink usually is from quite shallow wells. The gas is usually, not always, hundreds to thousands, usually thousands of feet deeper. And so this, you don't want this stuff in your drinking water. You don't want gas in your drinking water. Well, both these things have happened. They don't usually happen, but they can happen. And so if you have fractures in the geology, it's possible to have fractures that would go through thousands of feet of geological formation, so that this fracking fluid would work its way up into a water supply. That's rare, but it's possible. How'd you heat your house this winter?
Gas. Gas.
Okay, how would you like to not heat your house next winter?
Are we at risk of that? If we don't hydrofrack, that we wouldn't be able to...
If it was not for horizontal drilling, our gas production from conventional fields is dropping like a stone. The only thing that's keeping gas production more or less level is that it is this hydrofracking. Now, it's still only 20% or so of gas production, but as conventional gas production is dropping, the hydrofracked gas is increasing. The other thing that's going on is that because we have an economic recession, we're using less gas. So that means that the demand is 5 or 8% less. So that makes it that we need it a little bit less than we might otherwise. So the question is, if I give you a choice, you want to stay warm in the winter, or do you want to have clean water? I'm a scientist. I'm not in the business of telling you or society whether we should bother or not. I can try to tell you some of the things. We do know that each well only gets a lot of gas for a year or two. Then you have to drill another one. You have to keep drilling a lot.
So we might get the energy for a couple of years, but the environmental impacts might last for decades.
Yeah. I think you're arguing yourself into being cold in the dark in Buffalo.
I know.
There's no free lunch. All the energy choices are very difficult.
It's true.
Including this one.
You said...
As a citizen, I would say I think we have to do it. It's not as a scientist. Scientists have no opinion.
You have no opinion?
No, we're not. Scientists aren't in the business of providing opinions. We're in the business of, to the best of our knowledge, providing information and facts.